Okay, so this is a quick video to go over the lab DoNow that goes with golf range gizmo. And so there's a goofy backstory, as is typical with all of my questions. But basically, it talks about like a driving range. And so we have two questions, and one question says golfer hit a shot straight forwards from the elevated driving range. If it goes 250 meters in 3.2 seconds, with what speed did the golfer hit the ball? So here we have the range and we have the time, and we're trying to figure out the initial velocity. So we're kind of working backwards. And then for the second question, we have the initial velocity and the angle, and we have the time in the air, but it wants to know the range and how high. So let's take these problems one at a time. We'll start with the first question. Okay, so for the first question, we have that the range is 250 meters, 3.2 seconds worth of time in the air, and you want to know initial velocity, and the problem says that it was shot straight forwards from an elevated position, so that's going to be a horizontal projectile. And so there's like a little drawing, 250 meters is the range, and we want to know what was that initial velocity. So let's make a table of values. Alright, so things that I know are the range of the projectile, 250 meters, and I know the time in the air. I also know a few things from being a horizontal projectile, like the initial y velocity is 0 for all horizontal projectiles. I also know my accelerations. X acceleration is 0, y acceleration is negative 9.81 meters per second squared. Alright, now on a lot of these problems, we know the initial x velocity, and that is the same for initial and final, and we have to solve for like range or time. But now we have the range and we have the time, and we're trying to solve for the initial velocity. So I'm looking for VIX, like specifically like VI is going to be the initial y velocity is 0. So really what I'm trying to solve for here is what is the initial x velocity. And usually we start with these problems using the y information, but I have enough information in the x column to solve for the initial x velocity. I know the range, I know the acceleration, which is 0, and I know the time. So let's go from there. So I'm using d is v at t plus 1/2 at squared, because I know d, I know t, I know a, and I'm trying to solve for vi. Substitute with units. Tail end of the expression goes away because we multiply times 0. Divide both sides by 3.2. And I get that the initial x velocity is 78.1 meters per second. And there is my answer. That's pretty fast. And then you might say, it's like, well, that's the horizontal velocity. Here, let's write that in. Maybe we'll write that in green. 78.1 meters per second. And you might say, well, that's the initial x velocity, but it asks for the speed that the golfer hit the ball. Right, because there is no y component. So when you're hitting a ball completely horizontally, there is no y component, and all of the initial velocity is horizontal. So if you solve for that horizontal velocity, that is the initial total velocity. So 78.1 meters per second. Okay, number two. Number two asks for two things. It asks for how far did the ball travel, and how high did the ball go. We already have the time, so in order to figure out how far, we're going to need the time of flight. And so we'd have to solve for the time of flight, but we don't have to do that this time because we have the time. They tell us 7.36 seconds. It's a long time. Anyway, so let's give that guy a go. Okay, so based off the word problem, we wrote down the relevant information. We have initial velocity is 60 meters per second at an angle of 37 degrees. The time is 7.36 seconds, and it wants to know how far did the ball go and how high did it rise. Okay, so here's a little drawing and here's a little table for a projectile at an angle. Now, in order to start filling out the table, we're going to need the initial x and y velocities, which we don't have. We have the initial velocity and the angle, but we don't have the components, so we're going to have to find them. So here are the components. You can see that the x component is a little bit bigger than the y component because the angle is lower than 45, so it's a little more horizontal than vertical. So let's put those velocities into the table. And now we can start filling out some other stuff too. X acceleration is always 0. I don't care what kind of projectile you have, just as the y acceleration is negative 9.81 meters per second squared always. And then, all right, so that x velocity continues at 47.9 meters per second. And then the y velocity at the highest point is 0. And at the end, it's negative what it was to start. So negative 36.1 meters per second. And we know the time, we know the total time is that's to top. The total time is 7.36 seconds. And so the time to the top is half the total. And so half of 7.36 is 3.68 seconds. Now, we do not know how high and we don't know how far, but those are the things they're asking us to solve for. All right, so let's start with how far, because that's the first one I asked for. And so I know time and I know acceleration, so I can do a d is VIT plus 1/2 AT squared using the total time, not the half time. Now, you could use the half time, but then that range that you would get would only be the halfway range. So then you would just need to double it. But anyway, so we have the range, initial x velocity, don't put in 36.1, don't put in 60. We have 47.9 meters per second. We have the total time of 7.36 seconds, and then we have no x acceleration. So that is going to, that back end of the expression is going to fall off. So we have 47.9 times 7.36. And so that ball goes 353 meters. Again, we're in like a low gravity environment here or something. Or rather, no, it's 9.81. We're in a no air resistance environment. Sorry, it's not low gravity. It's normal gravity. But it's it's an evacuated mall. It's in a vacuum. There's no air resistance. So anyway, 353 meters. That's pretty far, but that is how far the ball goes. Now, how high does it go? Now, for this one, we don't want to use the total time because we're going to wind up with a d of 0, which is mathematically accurate, because at the end of the total time, the displacement, the ball comes back down to the ground, and so the displacement is, in fact, 0. We want to use the time to rise. And so same equation, except I'm going to be using the y information. And we're using the time to the top, the half the total time. So the height is going to be the initial y velocity, which is 36.1 meters per second. The time is going to be to rise, that's 3.68 seconds, and then gravity is going to act against us. It's negative 9.81 meters per second squared, and then we put the time in again to rise, and don't forget to square that sucker. And so when we work the numbers, and we get 200 meters up into the air, that's pretty wild. So 199 meters is how high. And so those are the two parts there. Maybe we can bring that back. Nah, we'll just leave it as is. So yeah, 353 and 199. So yeah, the first question here, that was a horizontal projectile. And then the second question was a projectile at an angle, solving for two different things. But the point of this DoNow, just as the point with all lab DoNows, is to help prep you for the lab activity itself. So I would give the DoNow a shake, especially if you find that the calculations, you're getting a little lost with the lab. Give this guy a look. All right, good luck, and hit me up with any questions you might have.